Okay, once again, good evening, and thank you for joining us for our winter weather spotter training. My name is Tony Edwards, and I'm the warning coordination meteorologist with the National Weather Service here in Charleston, West Virginia. So this winter weather spotter training will focus on the National Weather Service Charleston forecast area, and we serve 49 counties in Ohio, West Virginia, Kentucky, and Virginia. I know we do have some folks that register that were not in those areas, and that's fine. The information that we're presenting really much applies, most of it applies everywhere. So a little bit about me first. I'm the warning coordination meteorologist here with the National Weather Service office in Charleston. You can see my email there on the screen. Feel free to reach out if you have any questions or concerns or needs not addressed in this presentation. But I basically serve as a principal interface between the Weather Forecast Office and the users of its products and services. So I do a lot of outreach, and of course, the current circumstances require a lot of this to be done virtually. But in a way, it's a good thing. We've got currently 43 people in attendance to this webinar, and we had over 80, I believe, register. So I'm sure more will pile on. But it's a great way to be able to reach you and get out and talk to more people, even if it is virtually. So a little info on using GoToWebinar. If you're not familiar with how to use this, please ask questions throughout the presentation. And the best way to do that, especially with as many people on here, is to just type in a question in the box on your screen, the little GoToWebinar box. So if it's minimized, then you just click on the yellow arrow and it'll expand out. But there's a questions box in there. And you can, of course, type in your question. And what we will do is at the end of the presentation, I may break in the middle and answer some questions, but really at the end of the webinar, I'll go through and answer any questions that are in there. So feel free that as I'm speaking, as we're going through the slides and the information, if something piques your interest, you have a question about something presented there, go ahead and type in your question and we'll get to it at the end. And also, if you do have issues with computer audio, you can do phone audio by clicking on the little phone audio button there, and there'll be more information that will pop up there. Okay, so that's our background. So the bottom line up front, if you don't get anything else out of this approximately 45 minutes worth of material, it's that your observations of snow and ice are extremely important to us. And I cannot emphasize the extremely important part enough. Here's what we do with your observations. It may seem simple. You may send us a observation of snow or ice, and or maybe let us know that there's freezing rain occurring outside. Well, we adjust our forecast as needed in those situations. Maybe you're getting freezing rain and all we had forecast is snow. I'm going to talk a little bit about how challenging winter storms are to forecast. And so a lot of times we're kind of adjusting on the fly, and I don't know if you could hear that, but my dog JoJo's behind me here, so you may hear a dog occasionally, but she's my helper, so I can't shut her out of the office. So we do adjust our forecast as needed, and we send those reports that you send us out to the media and the world via local storm reports. That's an official National Weather Service product that gets sent out to everyone. The media are really interested in those reports. And you know, your report may help change someone's plans. If someone, maybe the media, pass on, for instance, I think this happens a lot, maybe 5 o'clock in the morning, people are just getting up, and maybe the local media, TV meteorologist passes on a report of snow and slick roads. And that may change that person's plans. And who knows, maybe even save their life that day just based on the information that you passed on. So we also use them for verification purposes, so we know how good or bad our forecasts and warnings were. And we also include them in post-event summaries, which are used by state and local emergency management and even FEMA. So your reports are extremely important to us, and they're important to a lot of other folks as well. So that's the bottom line up front. And we'll talk more about how to observe snow and ice and how to get those reports to us a little later on in the presentation. So here's where we're going. Here's the agenda. First off, we're going to talk about how bad winter can get around here. A little bit about snow climatology, some extreme winter storms and cold temperatures that we've seen in this area. It's been a while since we've had a harsh winter. Of course, tri-state region probably differs in that from last year with the ice storms. But as far as like widespread snow and cold, really cold temperatures. I'll show you how cold and bad it can get, and talk a little bit about winter safety. Then we'll go into how to properly observe and report winter weather, what to report, how to do it properly, and then how to send us those reports. And then we'll shift gears into forecasting winter weather. Why is it so hard to forecast winter storms, especially in our region? And then how to find winter weather forecast. And then we'll talk about the NOAA Winter Outlook and what it means for our region. So let's go into how bad winter can get. And I love history. I love weather history. And I love this quote from Winston Churchill. I talk about it all the time. You've probably, if you've taken a spotter class from me, you've seen this quote. The farther backward you can look, the farther forward you're likely to see. And so it's very important to know and understand our weather history. That way you have a good understanding of what weather threats we should be prepared for. And so weather records in our region date back to the late 1800s and early 1900s. In fact, we've got some river gauge observations going back into the mid 1800s. And of course, the history is kind of spotty back that far. But it is full of floods and severe thunderstorms and tornadoes and really crippling winter storms. And we put together what's called a natural hazard risk assessment webpage, and you can get to it from the link below on the slide here, or Google natural hazard risk assessment. It should come up pretty early in the results for our region. But you can click on the different tabs and see the various extremes and how these weather types have affected us. And I've got the winter extremes tab shown there, but this is a lot of information on this page that you can go to and look back and see just how just see what kind of weather threats that we really should be prepared for. So how much snow is normal for our region? Well, it varies a lot. So like I told you before, we forecast for roughly 49 counties in Ohio, West Virginia, Kentucky, and Virginia. And that basically goes from Greenup, Kentucky, all the way up to Snowshoe, West Virginia, and ranges in elevation. And that's goes from roughly 500 feet elevation to almost 5,000 feet elevation. And so you can see the variation in snowfall across our region from Grundy, Virginia, and in fact, some of our northeast Kentucky counties average less than 10 inches of snow per year, all the way up to almost 145 inches at Snowshoe at almost 5,000 feet elevation in West Virginia. So a wide range there. In the Metro Valley, even we range from around 20 inches in Huntington up to about 32 inches in Charleston. And so a wide range in snowfall amounts for our region. Now, when you look at emergency and disasters that have hit our state, I thought it was interesting. You know, flooding is our main weather disaster in the state. It's what affects us most. And we've had over 40 different federal disaster declarations in the state of West Virginia alone. This is just West Virginia I'm talking about here. 42 of those, but 8 have been winter storms. And if you include Hurricane Sandy, which was a winter storm in West Virginia, then that brings that total up to 9. So winter storms are a major threat in our region. And specifically snow, how much snow can we get? Well, snowstorms are not frequent, but they have paralyzed our region for days and caused major hardships on the population. I'm going to talk a little more in depth about the November 1950, the Great Appalachian Storm, here in just a minute. But the graphic over on the right shows the record one-day snowfall totals in each county in our forecast and warning area. And so that ranges from a foot in Boyd County, Kentucky, and Benton County, Ohio, Perry County, Ohio, all the way up to 3 feet of snow in one day in Nicholas County and Randolph County. The top 3 snowstorms for our larger cities include almost 26 inches in November 1950 in Charleston. And you'll see that 1950, that November 24th through 29th, 1950 date at most of our climate sites, because that was really the record snow for most areas in our region. I'll talk a little bit more about that in just a minute. But one-day snowfalls of a foot to 3 feet have occurred, and multi-day snowstorms have produced up to 62 inches of snow. And there you see November 1950 again. So here is some more information on that Great Appalachian Storm of November 1950. The regional snowfall index and snowfall totals on the left show that a large area of Pennsylvania, Ohio, and West Virginia recorded over 24 inches with over a foot of snow all the way back into eastern Kentucky and southwest Virginia. You can see some of the totals. Coburn Creek, West Virginia, that's the record snowstorm in our region. 62 inches of snow fell. And the big thing about this storm was how long it happened. It started on the 24th, early morning on the 24th, as an Arctic front moved through, and snow really didn't end until the 30th of November. So just a long duration snowstorm with winds over 30 miles per hour at times and temperatures plunging into the single digits. So just a siege of winter storm on the region, and over 160 folks lost their lives in this storm. So just imagine, this was back in the 50s. Imagine what would happen if this were to occur today. And hopefully we would have more, better forecast and warnings out and know much further in advance that this was coming. And our infrastructure is a lot better in many regards. But a storm such as this, if it were to occur this winter, would have a major impact on our region, and just not be a good situation. And like Winston Churchill said, if it happened in the past, it can happen again in the future. Now, how cold can it get in our region? This says West Virginia, but we're actually talking about our entire 4-state region. Most of our region has experienced temperatures as cold as 20 to 30 below zero. You can see the record cold temperatures for each county on the right. And again, this is all available in our Natural Hazard Risk Assessment webpage, these maps for future reference. But we do have several counties that got to 30 below, 35 below, even almost 40 below. In fact, the record coldest temperature observed in our region was 39 below zero at Milligan, Ohio, which is in Perry County. And a close second was 36 below zero at Snowshoe in 1985. Other notable cold spells you can see here: 1912 is 34 below zero in Barber County. 1963 in January was 30 below in Nicholas County. January 1985, 36 below at Snowshoe, 26 below down in McDowell County, West Virginia. And in 1994, a lot of records were set on January 1994, 31 below in Carter County, Kentucky. And in February 2015, pretty recent, 6 years ago, 23 below zero in Dickinson County, Virginia. So that gives you a good idea of how cold it can get. And this is not factoring in wind chill. So oftentimes wind chills can get even colder than this. So when we're talking about winter weather and winter weather safety, it's important to know the terminology. And we issue these products in the winter to keep you alert for severe weather. Now, you may get these alerts on your local media or on your cell phone or on an app, but these come from your local National Weather Service office. And they include a winter storm watch. And this is issued when our confidence is medium that a winter storm could produce significant impacts from snow, sleet, or freezing rain. And confidence, say about 50%. Say we're 50% confident that a winter storm is going to affect our region, then usually a couple days in advance we will issue this winter storm watch, and that's your heads up. When we get our confidence increases to above about 80% that a major winter storm is going to hit our region, then that's when we issue winter storm warnings. And so when the warning's out, that's when you need to be wrapping up your preparations and prepare to really hopefully just stay home if at all possible. And for lesser events, when we have high confidence that mainly light amounts of winter precipitation are going to affect our region, then we issue a winter weather advisory. So that's a little bit of the terminology. Now, the number one best thing you can do to be prepared for a winter storm, a flood, any kind of natural or man-made disaster is to build an emergency supply kit. And so there's some great resources at ready.gov/kit. Here's a list of things that you might want to include in your emergency supply kit. But basically, you want 72 hours worth of food, water, and prescription medicine, and then anything else that you need to make your life comfortable for that 72 hours. And include your pets. They need food and water, so you got to include that. So here's just a few items that you might want to include, but basically just do a little mental exercise and think about what you would need to be comfortable for 72 hours in the event of a disaster, and put that in a kit and keep it stocked up and ready to go. And so again, go to ready.gov/kit for more resources, more ideas on what to include in that kit and how to keep it fresh and everything. And also don't forget your car. Most winter emergencies happen in vehicles, so you want to have an emergency supply kit for your car. Include a first aid kit, jumper cables, spare tire, flares. Keep your gas tank full. Keep some kitty litter or sand in there so it'll help you get traction if you were to run off the road. Tow rope, blankets, extra clothes to stay warm, shovel, flashlight, of course, water, snacks, and a cell phone charger. You can even get ones that are the word left me, but you can make sure to keep your phone charged. Solar power, there we go. solar powered phone chargers. So so don't forget that vehicle. And when you are traveling, maybe you're heading out on a winter or a road trip and there's winter weather involved. Be very, very careful. Take it slow in the snow, and if temperatures are near freezing, drive like you're on ice. If you see that the temperature's hovering around freezing on your car thermometer, just keep in mind that you could be driving on ice. So keep it slow and be careful. Check the forecast and the road conditions on the route between you and your destination. That's very important, especially if you're traveling over the mountains, higher elevations. Know what that forecast is at those higher elevations. It could be drastically different than where you're at now. And each year, more than 5,000 people are killed and more than 418,000 are injured due to weather-related vehicle crashes. So it's very important to be prepared and be ready with your vehicle. And finally, snow squalls. So snow squalls are something we don't get very often here in our region, but they can cause major issues and have caused some really large pileups, especially in Ohio and Pennsylvania and across our region. They've also had some impacts as well. So these are intense bursts of snow and wind. Looks like a blizzard occurring, but the sun may be out 1 minute and then a blizzard the next, and then the sun's out 15 minutes later. But in that 15 minutes, a lot of damage has been done due to the low visibility and rapidly deteriorating road conditions. And so we actually issue snow squall warnings in the National Weather Service now for these events. This will be the second winter that we've issued these when they do occur. And these particular warnings will trigger wireless emergency alerts on your cell phone if you have those enabled. And so we typically keep these limited in duration, 30 to 60 minutes for a small targeted area around interstates, major highways. And one thing we are really shying away from is issuing these late at night, since they are mainly geared towards travelers. And so, but that is a product that we will issue. So if you see those snow squall warnings, you see the DMS signs on the interstates warning you of snow squall warnings, then this is what we are predicting, and that's these high impact, short bursts of snow and wind that can make for very treacherous travel conditions. And some other considerations. Hypothermia. Hypothermia occurs when your body temperature drops below 96 degrees. It does not have to be extremely cold for hypothermia to affect you, especially if you get wet. It can be in the 50s. And if you get wet and your clothes get wet and your body core temperature drops, and you can suffer from hypothermia. So if you or someone you know shows the above signs of hypothermia, get medical attention immediately. And those signs include confusion, shivering, difficulty speaking, sleepiness, and stiff muscles. And then now's a good time to winterize your home. Inspect, clean your chimney, especially if you don't use it very often. And I remember last year we used our wood burning stove quite a bit during the ice storm when we lost power. So you want to make sure that that chimney's clean, and that way that you don't run the risk of getting a chimney fire when you are forced to use it in the event of a prolonged power outage. If you have a backup generator, now's the time to make sure they start and the carburetors aren't gummed up and got fresh gas in them. And when you do run generators, make sure to keep them away from homes and garages. Do not run them indoors or close to a window or door where that carbon monoxide could possibly get inside your home. More safety information, winter considerations are available at the website at the bottom there, weather.gov/safety/cold. So that's a little bit about winter extremes and how to stay safe in winter storms. So now I want to talk about how to properly observe and report winter weather. So like I said before, your observations are extremely important to us, and this is what we need to know about. So we need to know about anytime you're getting snow, sleet, or freezing rain, the measured amounts from that. And oftentimes it's as simple as just sticking a ruler in the snow on your porch railing or a picnic table and maybe tweeting that to us or sending us a Facebook message, or we have a lot of other ways, which I'll talk about in a minute, to get those reports to us. But intermediate reports during the storm are very helpful to us, especially if you're a night owl and you're up at 3 in the morning. Man, that would be extremely valuable to get that report, because those late night reports, early morning reports are hard to come by. So those intermediate reports during the storm, and then one final report at the end of the event, would be fantastic. Anything we can get, we truly value those reports. There's something called the MPing app, which I'll talk about in just a minute, but that allows you to report different types of wintry precipitation, whether it's freezing rain, snow, rain, sleet. Makes it very easy to report that, and that is also something that we need to know about. Is any occurrence of freezing rain is very important due to the impact it can have, but then those changeable precip types. I want to talk about winter storms and forecasting winter storms. And one of the things that about winter storms is we are almost always on the dividing line between rain and snow and freezing rain in our region. So very rarely do we just get all snow across our region. So we're always wondering where that rain snow line is, who's getting the freezing rain. All that's extremely valuable information to us. So how do you properly measure snow and ice? Well, you need some supplies. And so you need, the best way to do it is to take a snowboard, which is a 2 foot by 2 foot piece of white plywood, painted white if you don't, if you want to paint it, or a flat surface like a picnic table or a porch railing, just something flat. We ask that you not use the grass. Don't measure your snow in the grass because it will artificially inflate the total. 2 snowboards are great if you're going to use them, because you can have one to measure the new snow and then one to measure the snow depth, which we'll talk about more in just a minute. But if you are using a snowboard, place it on a flat surface, a flat patch of grass away from trees and other obstructions. And you might want to mark it with a flag. Maybe we get one of those record snows and you're kind of wondering where your snowboard's at to measure it on. If you have it marked with a tall flag or some other way that you have it marked and you know where it's at. So that's the basic supply that you need to measure on. Just a flat surface will do if you want to do the snowboard. But then you need a ruler or a yardstick. And, you know, we don't get a whole lot of snow here usually in the yard category, but a ruler is typically fine. And we prefer measurements in 1/10 of an inch. And most folks have rulers that are measured in fractions of an inch. And so that's okay. If you have a ruler that measures in fractions, then just give us that measurement and we'll convert it for you. There is a link at the bottom of this slide. And again, these slides will be posted on our spotter page, and we'll follow up with that. But this has a much more in-depth information on how to measure snow. And we'll talk about cocoa raws here in just a minute. And there's a lot of really good training, in-depth training, more than I'm going to go through in this presentation for our needs, available on there. So what do we need to know about? How do you take your measurements? Well, we need to know about it as far as snow goes, new snow and snow depth. And oftentimes those are the same, but if you get a prolonged winter storm or you get a snow that follows a previous snowstorm, then they may not be the same. But new snow is just what it says. It's accumulation of new snow since the storm began or since you took your last measurement. We don't include any old snow that may be hanging around in that measurement. And ideally, you measure new snowfall as soon as possible after it ends, before settling or melting can occur. And this is really important when we talk about snow squalls and snow showers. You may get a snow squall move through at, say, 4 o'clock in the afternoon, and that lasts 15 minutes, but you might get an inch of snow. But if you wait, you know, the sun's going to come out, and by 5 o'clock, there may not be any snow on the ground at all. So you want to get that snowfall measurement as quickly as you can. So that's new snow. It's measured in 1/10 of an inch. But again, if your ruler doesn't measure in 1/10 of an inch, you can give us the fractional amount, and we can convert it. And then the other measurement, snow depth. And again, most of the time, this is going to be the same as your new snow, but sometimes it may not. And so this is the average depth of snow on the ground, including any previous snow that may be hanging around from previous storms. And oftentimes snow depth, especially as a snowstorm has moved off and maybe the snow pack is melting, the snow depth is not uniform. So you'll need to take several measurements and average them together. So that's the 2 measurements that we deal with when we're talking about winter storms. Now, if you want to be a climate observer or a cocoa raws observer, which we'll talk about in just a minute, there's some extra measurements that you would take and some additional training that you can take on that. But for our purposes, for our spotters, if you can just pass on those 2 reports of new snow and snow depth during winter storms, that would be fantastic, and we would really appreciate it. Now, what about ice? So we were pummeled by the ice storms, back-to-back ice storms in the tri-state region last year, and so really a debilitating winter storm. And for spotter reports, there's two types of ice accumulation. There's flat ice, which is just what it says, it's ice on flat surfaces, or there's radial ice accumulation, and this is the ice accumulation on power lines and tree branches. And so we will take either one. We just need to know how you took the measurement, because there is a difference. A half an inch of flat ice does not equal a half inch of radial ice. And I've got an example down below. So if you want to take a radial ice accumulation measurement, the best way to do that's on a tree branch. And you can see in this particular example, we have this ruler is broken out in tenths of an inch. And these are measurements I took from my house in Hurricane, West Virginia last February during that winter storm. And you can see, and this was taken at the same time. So you can see on the left that the tree branch here, including the entire tree branch, is about a half an inch of ice thickness. But the way that you measure this is there's often a difference between the thickness of the top of the branch and the bottom of the branch. And so what you want to do is measure both of the thicknesses and then average them together. So in this particular example, you've got 3/10 of an inch of ice on the top of the branch and then 1/10 of an inch of ice below the branch. And so average those together and you get 2/10 of an inch of radial ice accumulation. And that's how you should pass on your report, 2/10 of an inch of radial ice accumulation. Now, here's the flat ice accumulation, and this was the exact same time as this picture was taken. You'll notice that it's kind of hard to see, but my ruler measures almost exactly a half inch of flat ice accumulation. And so you would just simply measure from the top of the flat surface, such as a metal post or porch railing, and if you have to, you could chip into the ice down to the surface and then measure it that way. But an example here is a half inch of flat ice accumulation. And so typically speaking, flat ice equals radial ice divided by 0.4. And that's how that's a typical equation to compare the two. But again, we don't care how you take the measurement, just let us know whether it's flat ice or radial ice accumulation if we are to get another ice storm. Very important. Ice is something that we struggle to get accumulations from. And so if you can get those accumulations, of course, do it safely. Be very careful walking on a patio or a porch to get these measurements. As I don't want you to fall and hurt yourself. But if you can do so safely, get these reports to us, and that'll really help us out. So how do you send us your reports? Well, if you go to our webpage, which is weather.gov/CharlestonWV or weather.gov/RLX, or you can go to weather.gov and just click on the state of West Virginia is the easiest way to get to our webpage. And look for the little green icon with the person looking at the thunderstorm. And if you click on that, that'll take you to a web page that will give you in-depth information on how to send us your reports for winter weather, for severe weather, whatever. There's several different ways to do that, including a web-based form that you can go to, and it works pretty good on a cell phone. You can also use our spotter hotline given out to trained weather spotters, and I'll give you a little more information on that towards the end of the presentation. We're on Facebook. It's great to, if you can snap a picture of your ruler in the snow and send it to us on Facebook or Twitter, that's fantastic. We'll retweet that. We'll share that. You can email us if you're not on social media. You can email us at rlx.ops@noaa.gov, and then also the MPing mobile app. So MPing is a app on your Android or Apple device, any cell phone. You can download that, and it makes it very easy to send a report of what kind of precipitation you're getting at your location, whether it's rain, snow. You can also report hail size using that app. So please download that, use that during winter storms as well. And then at the bottom of that page is some links to see the reports that have come in. And so you can look at local storm reports during thunderstorms, rainfall reports, and snowfall reports, all by clicking on the links there. And these are your reports. These are reports that you're sending in, that we're getting from highway garages, that we're getting from emergency managers, that we're getting from social media. We send those out, and you can find them during a storm at those links. So that's weather.gov/RLX/reports. or you can get to it by looking for the little green icon with the person looking at the spotter looking at the thunderstorm. That'll get you to the reporting site if you are not in our forecast area. Now, CoCoRaHS is kicking it up a notch. So if you're really interested in weather and reporting winter weather, then CoCoRaHS is a volunteer network of weather observers working together to measure and map precipitation in their local communities. So these can be individuals, these can be municipal locations such as fire departments, water plants, DOH garages, or even a program tailored for schools with lessons plans and teaching aids. Just Google CoCoRaHS for schools and it'll take you to that information. But it's very important to have trained observers in your county for FEMA disaster declarations for winter storms and also for climate monitoring purposes. And so if this interests you, if you want more information, go to the link there at the top of your screen or Google CoCoRaHS and help us fill in the gaps on the map at the right by signing up and starting to observe the weather, rainfall and snowfall in your location. That would be a big help to us. So hopefully that's clear. If you have any questions on how to observe or report winter weather, feel free to type them in and we'll get to them. But I want to shift gears and go on to forecasting winter weather. So why is it so hard to forecast winter storms in our region, and how do you get winter weather information? Well, forecasting winter storms involves getting 3 ingredients right, and that's cold air. Of course, you need that for snow and ice to form, and air must be below freezing in the clouds and near the ground. You need moisture, and you know, that could be the Gulf of Mexico, the Pacific Ocean, the Atlantic Ocean, and typically we don't lack moisture in this region, as it typically comes from the Gulf of Mexico. But you need lift, and that causes moisture to rise and form clouds and precipitation. But the most important factor in trying to figure out who gets what is surface low track, and that's what we really try to key in on. And we looked at all the top 10 winter storms for Charleston. And really, it doesn't vary a whole lot across our entire region, but this is a particular example for Charleston. So if you take it all the top 10 winter storms for Charleston, and all those storms had over a foot of snow, and you look at the surface low track, they're clustered very closely. Basically, you have a low that travels up from around New Orleans, southern Mississippi, up through central South Carolina, over into eastern North Carolina, pretty much over Norfolk, Virginia, between Richmond and Norfolk, and then off into the Atlantic. And this low track really hammers West Virginia with snow. And so that's our favored low track if you like a big snow for our region. So that's something that you can look at if you like looking at the computer models and the forecast. If you see a low track tracking in that area and you got cold air in place, that's a good sign that we're going to get a lot of snow. Now, winter forecasting is very difficult because we not only need to get the temperature right at the surface, but we also have to get the temperature right all the way up the atmospheric column, all the way up as far as you can go. And sometimes and oftentimes actually in our region, west of the mountains, there's often a wedge of warm air that comes north. And it typically comes west of the mountains, and it can warm us up and cause a lot of the lower elevations, the Ohio Valley, to be rain, where we get snow up in northern Ohio into Pennsylvania. So when snow falls out of the clouds, but it encounters this really large wedge of warm air, signified by the orange here in this graphic, then that snow melts and it reaches the ground as rain. When that wedge of warm air is pretty thick and causes the snow to melt, but then the surface temperatures are below freezing, then that's when you get freezing rain. And sometimes this can happen when even rare occasions the surface temperatures are above freezing. If we've come out of an extended period of really cold temperatures and the asphalt and road surfaces are below freezing, then it can be above freezing and rain can freeze on those surfaces. Now, when the layer of warm air is relatively thin, but it's still thick enough to cause the snow to melt into rain, but then you have a really thick layer of sub-freezing air down to the surface and you get sleet. Those raindrops refreeze into ice pellets and sleet. And then, of course, when your temperature is sufficiently below freezing through the atmospheric column, snow falls. And so that's why it's really difficult to forecast winter storms, is because we need to get the surface temperatures right, and we need to get the atmospheric temperatures right above the ground. And the problem is we have a lot of surface observation locations. So we have a lot of sensors at the airports, and we have mesonets that are positioned out there to let us know what the temperature is at the surface. It does vary a lot in the hollers here in our region and up in the mountains, but we have a pretty good idea what the surface temperature is. However, we rely on upper air balloon launches to tell us what the temperature is, say 5,000 feet above the ground. And as you can see on the map here, we are strategically located between upper air balloon launches. There's one in Wilmington, Ohio, Pittsburgh, Washington, D.C., and Roanoke, Virginia, but nothing here in West Virginia or the tri-state region. And that's often where that wedge of warm air comes northwest of the mountains. So very difficult to forecast winter storms here. Just 1 or 2 degrees difference at 5,000 feet above the ground will often mean the difference between a foot of snow or 1 inch of cold rain. And it's literally that tight of a margin. 1 to 2 degrees can make all the difference in the world. So that hopefully gives you a little bit of an idea of why it's so difficult to forecast winter storms. Now, how can you get winter weather information from our webpage? Well, all weather service offices have comprehensive winter weather forecast information, and in our office and in the eastern region of the weather service offices, you can look for the little blue snowflake icon on the webpage and click on that, and that will open up our winter weather forecast page. And there's a vast array of winter storm related forecast information, including amounts, potential extremes, timing, and impacts, all on these pages. The menus and tabs have been streamlined. This page has been around for a while, but they've been streamlined so they are the same no matter which National Weather Service office you're looking at. We've got some new graphics packages this year, and also statewide graphics are available for snow and ice accumulation. So I've got links here for West Virginia, Ohio, Kentucky, and Virginia. Basically, the West Virginia statewide graphics are available on the Weather Service Charleston winter page. For Ohio, you need to go to the Wilmington, Ohio winter page. For Kentucky, you go to the Louisville, Kentucky winter page, and that'll take you to the statewide Kentucky graphics. And then for Virginia, that's the Richmond, Wakefield, Virginia office, and they have the the statewide graphics for Virginia. So this is a great resource to go to when snow is expected. And one of the first things you'll see is our expected snowfall amount, but we also show you what are the potential high-end amounts and low-end amounts based on the computer models that we look at. There's always a range of potential outcomes with winter storms, and you can find that information. You can find onset, ending time graphics. There's also a link to the Winter Storm Severity Index, and you can get to this page with the link on your screen. And again, I'm going to have these slides uploaded onto our spotter page in a PDF format. You can also watch the video, but so you can go to these, you can check these out later. But this Winter Storm Severity Index is linked on our winter page, and it provides winter storm impact information out to 72 hours with a new experimental day 4 and new 6-hour visualization option. So you can go and look at various meteorological and non-meteorological factors, such as the weight of the snow. How big of an impact is that going to be? Is it going to be heavy, wet snow or light, fluffy snow? The snow amount, the ice accumulation, if there's going to be a ground blizzard, which luckily we don't see much here, but out in the plains they do. Flash freeze. So sometimes we get precipitation that ends and then the temperature rapidly plummets below freezing, setting up a situation where you get a flash freeze and black ice on the roads. This Winter Storm Severity Index will pick that out as well, and then blowing snow. So this is a great tool that, again, is a link from our winter pages, and you can check out, and we'll show in our briefings and stuff this winter, and on social media, share to give you a better idea of, you may be getting 6 inches of snow, but maybe it's going to be a light fluffy snow and not have the impact, or maybe it's going to be a heavy wet snow and have major impacts. This tool really kind of picks that out and showcases those differences pretty well. A revamped product that we have is called the Graphical Hazardous Weather Outlook, and this can be found by looking for the brown icon on the Weather Service web pages that has the 4 hazards on it, or you can get to it from the link on your screen. And so when you click on the icon there, this will bring you our experimental graphical hazardous weather outlook. So this is really a quick way to get briefed on what weather hazards are in the forecast over the next week. The hazard graphic map map changes by clicking on the colored chiclet icons in the hazard matrix. And we do have a statewide version as well for West Virginia and Ohio by clicking on the links on the slide here. And the other benefit to this is much more mobile friendly architecture than our previous version of this product. And so check it out. It's on our web pages and frequently updated, and just gives you that really quick way to get briefed up on what weather hazards are expected. Okay, so now we're going to shift gears into the NOAA Winter Outlook. And so talk about what it means for our region. And so hopefully you've seen the Winter Outlook. There's various ones out there. We have the Farmer's Almanac, the Old Farmer's Almanac, each of them showing a pretty rough winter ahead for us, if you believe those products. There's various winter outlooks out there, but NOAA produces their own winter weather outlook from the Climate Prediction Center. And our focus this winter is on La Nina. And La Nina is a pattern of abnormally cool water temperatures in the Central Pacific Ocean, which has long-reaching impacts on the weather across the entire northern hemisphere and really across the globe. And a moderate La Nina is forecast this winter, so those colder than normal water temperatures are expected to remain in place out in the Pacific through most of the winter. And typically La Ninas feature a storm track that favors a wetter than normal winter across the Ohio Valley, with warmer than normal temperatures over the mid-Atlantic and southeast. You can see on the graphic on the right that we're typically wetter and warmer than normal in our region. And so La Nina was the main influence on our weather pattern last winter as well. So this is the second winter in a row with a moderate La Nina in place. So what's our outlook for our region for precipitation? This map shows the winter outlook for December, January, and February. And it does appear that our chances of are pretty great of a wetter than normal winter for most of the Ohio Valley, especially west of the mountains. And so pretty favorable conditions for wetter than normal. And then when you get into the wide area over the West Virginia mountains down into Southwest Virginia, that's equal chances for below normal, normal, or above normal precipitation. So La Ninas typically favor a wetter than normal winter in our region, and that's the forecast that's the outlook for this winter as well. And so might have to deal with flooding. We dealt with it a little bit last winter, and so that is a concern this winter as well, that we will have above normal precipitation and some episodes of flooding. How about temperatures? Temperatures are expected to be warmer than normal. In fact, pretty high odds of a warmer than normal winter. Now, keep in mind that last winter's forecast was also for an above normal, warmer than normal winter. And so even though the overall winter is expected to be above normal, it will likely be punctuated with winter storms and snow and maybe even ice. So don't let your guard down just because you think the temperatures are going to be warmer than normal for our region. So what about snowfall? What's the outlook for snow? Well, Arctic outbreaks, ice storms, snowstorms are very difficult to predict more than 1 or 2 weeks in advance. Heck, they're pretty difficult to predict 2 or 3 days in advance, and even a day in advance sometimes. So the frequency, number, and intensity of these types of events cannot be predicted on a seasonal timescale. Looking at La Nina winters in the past, our region does tend to really shake out probably around normal or below normal average snowfall. So some major winter events have occurred during La Nina winters, including a major storm on New Year's Day, 1971. There was a major Arctic outbreak in January 1985. One of my first memories as a child was that event with some super cold air. Cold, snowy December 2010, and then of course we had the ice storms of February last year, in especially the tri-state region, and so that was also during a La Nina winter. So whether or not we'll have a major winter storm, it's too hard to predict this far in advance, but they have occurred in past La Ninas, and so it is important to be prepared for it. And in looking a little further out, there can be an increased probability of severe weather, and that includes hail and tornadoes during the spring months following a La Nina. So the graphic here breaks down El Nino's influence on the left, with tornadoes at the top and hailstorms at the bottom. Less frequent occurrence of severe weather in the plains and across the Ohio Valley, for El Nino, which is the opposite of what we're heading into this winter. And then the La Nina's influence is on the right. So it does indicate a more frequent occurrence of tornadoes and hailstorms during La Nina, following La Nina winters across the Ohio Valley and Central Appalachian. So that's something to keep in mind as we move out of the winter into the spring months. Of course, you know, last spring we really didn't see this trend bear through, as we really had below normal severe weather. So it's not a lock, but it is something that has occurred in the past, and there is a little bit of an influence there on severe weather when you look at climatology. So something to keep in mind. All right, so that concludes the winter outlook and our presentation. I just want to let you know that in about an hour after this presentation concludes, you'll get an email from GoToWebinar, and there will be an online form. If you're not a weather spotter, or maybe you're a trained spotter and your information has changed, you want to update us, you can fill that out, fill out that online form. And if you're not a weather spotter, you can register to become a spotter for us on that webpage. You can also complete an online form, and we will, or excuse me, after completing the online form, you'll receive an email with our weather spotter hotline number. So this may take a little while, especially with the holiday coming up, but be patient, we'll get that out to you. And then there's also a feedback form that we do ask for you to complete. It's optional, but your feedback is greatly appreciated. We'd love to know what you think of the presentation, what else you want to hear about in these types of trainings. And so that's it for us, and I'll look back at the questions now. Let's give me just a minute and get this broke out so I can read any questions that have occurred. Okay, so the first question I have is, can you have two spotter IDs if you live in two places? You can. We don't keep track of spotter IDs at this office, so if you just call us, tell us you're a spotter, tell us your name, we can look you up pretty quick. But yeah, if you've lived in two different places, you can have two spotter IDs, but we don't give those out here. Is there an easy way to distinguish between graupel, ice pellets, sleet, etc.? That's a very good question, and I didn't go into that here. It may be something I added for futures, because that is that's a very good question. So the easiest way to tell the difference is, graupel reminds me of styrofoam balls falling from the sky, because they're usually solid white and they bounce when they hit. Ice pellets, sleet, those are the same thing, and they're typically clear. And so that's the main difference between graupel and ice pellets and sleet. Now, graupel is formed really because of what we kind of think of almost like a thunderstorm in the winter, where you have this updrafts and downdrafts in the clouds, very showery, convective nature, and it causes graupel to form. But it looks like styrofoam balls. So that's the difference. MPing allows you to report those different types of precipitation types, and so you can differentiate between graupel and hail, or excuse me, graupel and sleet. All right, so hopefully that answered your question. Very good question. Here's a question from Clyde Campbell. Would PIREPs through ATC help, or are there too many delays in getting them to the right office? No, we monitor PIREPs. So if you're a pilot and you can send in those PIREPs, those are great. We actually get alerts on our workstation at the office for certain PIREPs that are in our area of responsibility, because we are in charge of forecasting for the airports, for the major airports, forecasting weather. So PIREPs are very helpful. So thank you. If you send those in, or send them in more often, that would be great. Let's see, from Rustine, do you think the new weather radar does better than what we had? Hoping also a nice winter for my farm's winter crop. Yeah, so the new weather radar, so we went through some upgrades recently, and we have what we call dual polarization technology with our radar, and some other upgrades, and they do help us really diagnose winter weather, especially because the dual polarization with the radar allows us to differentiate the hydrometeors in the atmosphere better, so we can tell what's rain, what's snow, what's sleet. Unfortunately, what is happening above the ground in the clouds that the radar sampling doesn't always make it to the ground in the same phase. So that's why we really need spotters. We need you all to send us those reports, because the radar may say that it's snowing in the clouds, but it may be raining or getting freezing rain at the surface. And that's where you can help us with those MPing reports. Those spotter reports are very helpful for that. Okay, is it warmer down by the river than the mountains? Very good question, Hunter. And most cases, that's the case. Usually the mountains are colder than the river. However, there are some situations where when you have good radiational cooling, you have a clear sky, calm wind, that cold air drains down to the valleys, and there's actually a ribbon of warm air in the mountains. And so the warm temperatures can be several degrees warmer on the mountaintops than in the valleys below. But typically for winter storms, yep, that's the case. You're colder at the mountaintops and warmer down at the valleys. Will reporting via ham radio be available? That's a good question, Seth. And we're moving to a new building coming up, I believe, in the spring, 1st of March, 1st of April, somewhere around in there. And we're going to have our ham radio equipment hooked back up, and going to do a lot of outreach with ham radio clubs around the region to try to get that going again. We've kind of failed in that arena for several years, and I'm hoping that with this new building and a new emphasis on the ham radio program, we can get more reports, because in offices I've worked at in the past, ham radio was a absolute fantastic way to get winter storm reports. Is I could get on the repeaters and get reports, and so it was fantastic. So yeah, hopefully in the near future, we still have let's see. Okay, Chris Hatcher, ham radio still in the office. Yeah, we have them, but we're having antenna issues in our current office, so we can't. They're not hooked up and functioning. But like I said, when we get to our new building, all that'll be in place, and we should be back on the air. How do I often get snow at my elevation with slightly warmer air when the valley below me will receive rain? So that's a good question, Michael. And you can actually get snow. It doesn't have to be below freezing to get snow at the surface. And so sometimes in the winter, while you may be above freezing, snow's falling from the sky, and you can get snow at your location higher up where it melts by the time it gets down into the valley. And so elevation in our region is a huge issue with forecasting winter storms, and that's why we need spotters. We need those reports, especially if you live on ridges. Let us know that, because the precipitation can vary greatly. So that's a good question. Okay, let me see, scroll down here. Okay, so Russ, you want to post the program to Facebooks? Yeah, you can do that. Like I said, what I'm going to do is I'm going to post this to our YouTube page, and then it will be posted to our spotter page. So hopefully I'll get this done tomorrow, and we're going to have that up there for future reference. And feel free to share it. It'll be in YouTube, so it's easy to share. So yeah, please do that. Great. All righty. And I think that's all the question. Fred Vickers, that's where are you moving to? So our new building is going to be at the West Virginia Tech Park, just off the interstate there in Charleston. So they're building us a brand new building there. Radar's staying where it's at there at Southridge, but our new building will be out at the Tech Park there. So really looking forward to opening it up. Hopefully with this this pandemic will allow us to have an open house and have some people over. But we're really looking forward to the new building. So. All right, I think that's all the questions. Thank you all for your attendance. We'll get you out of here, and I hope you have a great rest of the evening and a fantastic Thanksgiving. And really just thank you all for your attendance and the great work you do as spotters, and I look forward to seeing your reports this winter. Thank you, and have a great evening.